Welcome to another video, the same every time, IGCSE Maths, GCSE Maths, looking at the questions that apart from the numbers are the same every time. Learn how to do them, get yourself into the marks, get yourself into the grades. We're looking at probability tree diagrams. Now we use tree diagrams in probability when we have one event that happens after another event or one event that happens because of another event. And sometimes the probabilities can change. When the first thing happens, the first event happens, it can cause the probabilities of the second event to change. I need to tell you something about tree diagrams though first, before I even read the question here. Because I can fill in most of this diagram without even reading the question. And the way I know how to do that is because on a tree diagram, the pairs of branches have probabilities written on them, but the probabilities on each pair of branches always add up to make 1. So if this is 2/5, then this must be 3/5. Over here, on this pair of branches here, we have a 2/3 probability, so the other probability must be 1/3, because the probabilities add up to make 1. So already, without actually reading the question, I've been able to complete some of the question, and maybe I'm into the marks already. It's worth mentioning, I suppose, that on tree diagram questions on exams, very often they give you the tree diagram partly filled in, and the first thing they ask you to do is to fill in the tree diagram, fill in the missing probabilities. So already, without reading anything, I know that I can put a 3/5 and a 1/3 because the pairs of branches have probabilities that add up to make 1. I need to read the question now though. On any given day, the probability that it is sunny is 2/5. So the first thing that happens on our diagram, sunny, and we can either say yes, it's sunny, or no, it's not sunny. So that would be 2/5 for yes, 3/5 for no. When it is sunny, so the next thing, when it is sunny means we're looking at the yes possibility for sunny. When it is sunny, the probability that Zoran goes for a walk is 2/3, and so the probability that Zoran does not go for a walk is 1/3. And then when it is not sunny, so when it is not sunny, what do we have here? The probability that Zoran goes for a walk is 1/4. So when it is not sunny, probability of walk, so yes for the walk, is 1/4. So the matching probability here must be 3/4 because the probabilities, the pairs of probabilities on the pairs of branches must add up to make 1. So the first question says complete the tree diagram, and that's worth 2 marks, so I'm fairly confident I'm into the 2 marks there. When I'm doing a tree diagram question, what I like to do is write down every possible outcome. The reason I do that is because I know that it will be useful to me in answering the later questions. It doesn't take very long, so let's see what can happen. Going along the tree diagram, we can go this way and then this way. So that's yes for sunny, yes for walk. So that's sunny and we walk. And then the next thing, we could go again along the yes for sunny, but we do not walk. So that's going to be sunny, and I'll put NW for not walking. Now the next possibility is it's not sunny, and we do walk. So that's going to be not sunny, and we walk. And then the final probability, not sunny, and no for the walk, so not sunny, and we do not walk. So not sunny and not walk. Takes me a few seconds to write down all those options, but that's really going to be helpful to me later on in the question. And you can see why it's going to be helpful to me in the final part of the question here, which is worth 3 marks. So find the probability that on any day Zoran does not go for a walk. So what I need to do is look down my list of options and see which of these options involve not going for a walk. Well, this option involves not going for a walk. This option actually doesn't, so I'll just take that one off. So that option, we don't need that one, but this option here involves not going for a walk as well. So I've written down all my possible options, and now I've identified which of my options include doesn't go for a walk, so NW, not walk. So those two options. So to work out the probability of that, we need to include both of those options. And it's worth remembering this. When we're going along the tree diagram from left to right, we multiply. So sunny and not walk, I go along the sunny and then the not walk like that. So I multiply the probabilities. So 2/5 times by 1/3. Remember, in probability, and translates to a multiply. So sunny and not walking, 2/5 and 1/3. So not sunny and not walking would be going down here. So not sunny and not walking. So multiplying those two probabilities together is going to give me 3/5 and, or multiply, 3/4. So when we're going left to right on our tree diagram, we multiply, because that's an and situation. If we're going down the options, so going downwards, down the options like that, we must make a plus, because if you remember, in probability, an or translates into a plus. So basically we're saying the two options are sunny and not walk, or not sunny and not walk. So now calculator job for this one, I think. Use your calculator button. Do this yourself as well, just to make sure that you can get the answer. 2/5 times 1/3, and then plus, make sure you write it exactly as it looks. Just check your answer with mine. 3/5 times 3/4, and I've got 7/12. Now, some people sometimes ask with this kind of question, should I leave my answer as a decimal, or should I leave my answer as a fraction? Because, of course, we could write probabilities as fractions or decimals, sometimes percentages. My advice for this would be, if they're giving you fractions in the question, then your answer should be a fraction. If they're giving you decimals in the question, then leave your answer as a decimal. If this video was helpful to you, then please do press the like button. Please also subscribe to the channel. That's helpful to us. Thank you very much for watching. I will return in the next video.